everybody, and welcome back to another episode of What's the Word? I'm your host, Abby, and today we're joined with a very special guest. Today we're joined with David Hadley. And David, why don't you give us a little bit of background about yourself?
I just graduated from Embry-Riddle-Prescott campus in May of 2024 with a mechanical engineering degree, and I focused on the robotics track. So I started in August of 2020, this sort of tail end of COVID, and then, so spent 4 years down in Prescott and really enjoyed it.
Awesome. And do you have a favorite memory from your time at Embry-Riddle you'd like to share?
Yeah, so I think one thing I sort of look back on fondly would be our senior design capstone symposium for the detail semester. So the second semester of capstone, we presented our project. So just for a little bit of background, our project was called the Suborbital Reusable Vehicle, SRV. And the idea was to build a two-stage solid fuel rocket that was capable of hitting Mach 5 and crossing the Kármán line, and do it with a reusable vehicle that's capable of flying again and again for under $10,000. And so this was a research project, a URI project that we'd been working on for a better part of the 4 years we were at Embry-Riddle. And then we turned that into our capstone team. So it was four of us working on this project with Professor Garrick and Dr. Adams. And so for our detail semester, we were able to go through the whole design structure umbrella all over again. And for our final symposium presentation, we were able to fly the rocket sort of late November. Our detail presentation was December of 2023. So we were able to fly the rocket mid-November, and flight went great. We were able to recover the second stage, got a whole bunch of data, super successful, and it didn't fly as high as we wanted it to. And so we were actually able to bring the motor manufacturer on campus. We did a static fire of that motor to characterize the actual thrust curve of the motor we used. And then we were able to take that data, run it back through our 6-degree freedom model, and our predicted altitude and our actual altitude were within 400 meters, I believe. So we were able to verify our model was correct, and we just had bad data from the simulation of the motor instead of actual motor firing data. So it was honestly a really cool way to wrap up capstone and be able to present, hey, we did the flight, it was great, but then we also had this weird thing that didn't line up perfectly, and then we went and verified that, and now we can show sort of end to end that our process was correct, and for future verifying models for our vehicle. So I think that would probably be one of my favorite memories at Embry-Riddle.
Wow, that's definitely a really, really good memory, especially since you get to culminate all 4 years of that work into the one launch and it worked and everything like that. That's awesome.
Yeah, so we had the vehicle fly 5 times while we were students at Embry-Riddle. So this was sort of our final flight test while we were able to be students. So yeah, it was great.
That's awesome. Very, very cool. And were you able to take any of that information and knowledge you gained from that capstone and apply it to your current job?
Yeah, so just for a little bit of context, I'm now working at Garmin Aviation Technologies in Salem, Oregon. So Garmin obviously makes a whole bunch of different products, from outdoor gear, marines, auto OEM products, and of course aviation products, which a lot of the Embry-Riddle students are familiar with. So that would be G1000 integrated flight decks, and then the retrofit side of avionics. So that's GTN, which is a navigator. There's TXI, which is a PFD, a primary flight display. GI 275, which is a steam gauge replacement glass retrofit. So there's a lot of different aviation products that Garmin produces. And in Salem, we mostly are focusing on retrofit avionics. So I am working in the flight test group here in Salem. So we're responsible for writing the flight test plan. So how we're going to test and then eventually certify either new hardware or new software for the avionics. And then actually running test cards, verifying that the software is working correctly. And of course, working with the software and systems teams to work through bugs and do some iterative development there. And then finally, running actual certification tests and then writing up a flight test report, how the tests went. That's sort of a compliance statement for the FAA in order to certify our products and put them in certified aircraft, so class 1, 2, and 3 aircraft. And another part of that is technical writing, right? So we have to write AFMSs, so that's aircraft flight manual supplements. So every aircraft comes with an AFM, tells you performance values, limitations, emergency and normal procedures, all of that sort of stuff. And when you're adding retrofit avionics into an aircraft, we are obviously amending and changing the aircraft. So we have to add a supplement to the AFM and AFMS to adjust that. So there's a fair amount of technical writing involved in terms of flight test plan, flight test report, and writing FMS documents. The AFMSs are then provided to the end customer as a document they have to have with them in order to correctly use their aircraft. And so in flight test, we're responsible for then writing all of those. So the technical writing skills, especially that I gained during our capstone project, both preliminary design and detailed design, have proved really helpful in terms of being able to write, concise documents that, with a very clear audience in mind. So that experience, both from our tech report writing class and from capstone, have proved quite helpful.
Wow, that's awesome. And so with your job, do you specialize in like the aircraft portion of the Garmin stuff, or do you specialize in like outdoor areas, or is it kind of all integrated?
Yeah, so it's only the aviation side. So it's all GTN, TXI, GI-275 are mainly the products we're focusing on. The other flight test organizations on the Garmin aviation side are responsible for doing G1000. G3000 Prime was just announced last month, I believe. It's a new all touchscreen integrated flight deck. So it's all the aviation products. We tend not to touch any of the outdoor products, any of the marine or auto products, that sort of stuff.
Oh, okay, awesome. And do you have a favorite part of your current job?
Well, the easy answer is flying. Part of our job obviously involves doing actual in-air testing of the avionics and the software associated with that. And so it really is hard to beat, taking up one of the aircraft we have here in Salem and doing some testing on whatever hardware and software stack we are working on at that time. Salem's back in the Pacific Northwest, so it's nice to be surrounded by greenery, and we're only, a 20-minute flight from the Oregon coast. So I think actually on my first day at Garmin, we were flying along the Oregon coast and we're able to see some whales, which was pretty sweet. So that's obviously pretty hard to beat. And, obviously that privilege to be able to actually go up in the air and do flight testing comes with our strong safety culture. We do structured pre and post-flight briefings, and then lots of preparation before and afterwards, giving feedback to other teams at Garmin and how we need to continue development of the products.
Awesome. That sounds very fun. Kind of a fun
Yeah.
little treat inside of work that you get to go fly, and especially around the Oregon coast and everything. That sounds beautiful.
And it's really a great way, trying to find a way to combine both mechanical engineering and my love for flying. I got my pilot's license and I've been working through my ratings. I just got my multi-engine rating in June. And so a way to sort of combine GA flying and engineering, I think this is sort of a great fit. So I've been enjoying it.
That's awesome. Congratulations on just getting your multi. That's very exciting. And so, what does a typical day look like at work?
I wouldn't say every day is the same, but a typical day probably consists of some combination of different coordination meetings, coordinating with the certification team on whichever project we're supporting, and so coordinating with all of the different other teams on site. So we have systems and software and cert sort of in our world that we interface fairly often with. So in flight test, if we find an issue while we're flying, we'll write up a bug report, and then that bug report will then go to the software teams. And so we'll attend software meetings to help highlight which problems are high priority, to help explain issues, and sort of keep everything on track and coordinate with the software team to keep the ball rolling forward. So definitely some meetings involved. You can't really escape those. And then sort of depending on the time of year, our ability to go flying varies. We'll typically get up for a flight several times a week to do either development testing or preparation for certification flight testing. We'll have a list of things we want to hit in terms of new features that we want to test, edge cases we want to find and better understand in the air. We obviously have the ability to do testing on the ground, but that's really hard to replace testing in the air where you get all the systems working at the same time and can really understand how they're working. So typically some combinations of coordination meetings and hopefully a flight is typically how a day goes.
Awesome. That's very cool that you get to tie your hands-on experience with the desk life. And so, are you able to tie writing into your day-to-day life a lot?
Yeah, for better or for worse, I do end up doing a fair amount of writing. So as I alluded to earlier, the AFMS, the Aircraft Flight Manual supplements. As flight test, we're responsible for drafting those documents, and those are typically pretty large documents that outline all of the different system descriptions, the limitations, both emergency and normal procedures, and then there's a description section. So we're responsible for writing all of those. So writing technical, but also concise and pilot-friendly jargon that the pilots can understand and interpret. Preparing for a flight and understanding what the limitations of the system are is quite important. So that's one aspect of the technical writing we do, and that involves a fair amount of coordination, understanding the system, understanding what its limitations are, thinking, okay, well, if this screen fails, which of course we never want it to, but if this screen fails, if this sensor fails, what procedures and steps you need to take. So then writing, emergency procedures for all possible scenarios, going and testing and verifying those procedures in the air. That's something we do a lot of. And then on the other side, writing a flight test plan and a flight test report. So a flight test plan is what we give to the FAA as a representation of what we are changing on this hardware or software and how that is going to be certified and how we're going to show that it's safe for use. A big part of that is writing test cards. So that's writing same idea as any other flight test organization, having test cards that tells the flight test engineer is reading off a card for the flight test pilot to then perform and verify that the actions are acceptable, that the system performs as expected. So writing cards that we can then verify and then use to then certify the new hardware or software. So that's a very, very specific type of technical writing that we're doing that can't have any type, if there's any typos or anything like that, those have to get redlined and revved. The document has to get a new revision for giving to the FAA. So very precise technical writing for that type of stuff.
Wow. And yeah, it definitely does sound like you write a lot concerning safety and the safety of your planes, but also the pilots. So would you say that word choice plays a bigger role in this, more so than other writing?
I would say that word choice does play a role, and I think in terms of mainly keeping it concise and to the point, right? But I think really the key is presenting the document in such a way to the pilot that, say you've just lost your engine power, right? As a pilot, you need to be able to read the procedure that says do X, Y, Z. And so word choice in that respect is very important. Or for example, GTN now has TAWS, which is the train alerting warning system. So it will alert the pilot if the aircraft is in such a configuration that you're at a high likelihood of hitting terrain. And so there's terrain avoidance procedures that are then in the emergency procedures section. Writing those procedures to be very clear that, if you hear the terrain, pull up, you should be doing X, Y, Z. That's where word choice and being very specific about what actions the pilot needs to take become quite important.
Awesome. Awesome. And so my last writing question for you today, have you noticed any big differences or similarities between the writing that you did while at Embry-Riddle and the writing you're doing in the workplace?
So writing about sort of systems and how they work is a majority of what my writing is focused on now. And there are definitely certain situations where I did a fair amount of that at Embry-Riddle. So, for example, in our mechatronics class, we had to write a 50-page report about this robot that we had designed and built with a low-level microcontroller, the Atmega 328P. And so we had built this robot with a whole bunch of different sensors, and it had to autonomously navigate this maze. And so we had to write sort of a system description, high level, and then break it down into how the electrical system worked, our design choices in terms of mechanical design, how our code was structured, the actual code, and commenting the code. But for that project, for example, a lot of that document was explaining how it works. And so similarly to what I'm doing now, when I'm writing an AFMS, a lot of it can be a system description. It's like, this is how Smart Glide is going to work. So if you have an engine failure, you can hold the direct to button on the GTN and it will get you advisory navigation to the closest airport and within your glide range of the aircraft, right? And so explaining how that system works to the pilot is quite important. And so in that respect, those sort of system descriptions, how the system works, are quite similar. And in other respects, I'm not writing memos or trade studies, that type of thing, in-flight test right now at Garmin. Whereas I did a fair amount of that type of writing at Embry-Riddle as well. So some classes more directly align with the writing I'm doing now, some not so much. But together, I mean, writing is writing in a way. Practice helps you no matter what, right? And so understanding your audience and the information that you need to convey is important regardless.
Right. Okay, I gotcha. And so that leads me right into my last question for you today. Do you have any advice for our current Eagles?
What I wish I would have known before leaving Embry-Riddle and what I would suggest to current students is, savor the time that you have while you're in college, right? It sounds silly to say, but, your weekends are free. If you don't have class on a day, you can go on an adventure, go on a hike. And that once you enter the workforce, those opportunities are fewer and harder to come by, right? So definitely take advantage of those while you can. And secondly, debatably more importantly, right? You're going to spend a majority of the time after you graduate at a job. And I think it's really important to find a job that you're passionate about. And I think it's worth remembering that not only is a company interviewing you, that in a way you're interviewing them, right? You need to feel comfortable and really feel like a cohesive unit with the team that you're joining. And so, think of those interviews as a two-way street. Like, can you really see yourself working with these people? Do they seem excited to talk to you? I think there's some companies that sort of drain people. And, when I interviewed at Garmin, I saw a company culture that I really liked. They were excited to talk to me, and I was excited to meet them. And so I guess what I'd say is, as getting towards your junior and senior year and looking for jobs is, think a little bit outside the box of what everyone wants to do and go out and look for companies that speak to you both in terms of people and in terms of product, right? As a pilot, right, I've used a lot of Garmin products for the entire time I've been flying. And so being able to be both a user of our products and now working on the products has provided me, a lot of different experiences and the ability to say, well, I'm also a user, so I understand the product from that side, and now I'm an engineer on it, and now I can understand it from this side. So I guess I'd say, yeah, find a company that excites you, that the products excite you, the work excites you. If you love your job, you never have to work a day in your life. That sort of thing is the idea, but it does make it much more enjoyable.
Awesome. And that is great advice. Thank you, David. So that wraps up this week's episode. Thank you so much, David, for being on with us.
Thank you for having me.
Of course, and we want to give David another big thank you for being on with us this week. It was a pleasure having you, David. If you are new to our podcast, you can find us on Spotify, Apple Podcast, or YouTube. Be sure to stay tuned.
This podcast is supported by the Department of Humanities and Communication at Embry-Riddle Aeronautical University in Prescott, Arizona. Our hosts are Abigail Bradbury and Owen Smith. Matthew Haslam is the department chair, and I'm Amelia Chesley, assistant professor of professional writing. Many thanks to the Prescott Campus Writing and Design Lab for hosting our transcripts. The intro and outro music is Wanderer by Alex. You can find us where most podcasts are found, and please do reach out if you are a Prescott Campus alum. We'd love to feature you in a future episode.